For this question, we have a quadratic, and we want to express it in this form over here. So to do so, we'll have to complete the square. Notice how we have a number in front of our x squared term, so we'll have to factorize out that minus 2. We can factorize it from the entire thing, take it out from the entire thing, or we can just factorize it from the two x terms that we have. So I'll do that instead, avoids having any fractions. So this then becomes 11, I'll take out a factor of minus 2, and then I will change the order of these two as well, so the x squared term is first. So x squared plus 2x. Now we can do the completing the square method with these two terms, so what's inside the brackets? F of x then becomes 11 minus 2, I'll use square brackets. So the x squared plus 2x becomes x plus 1 squared minus that 1 squared, close square bracket. So this in the square brackets is equal to x squared plus 2x. Then we can expand this out. So 2 lots of x plus 1 squared, and then minus 2 times, this will become minus 1. Minus 2 times minus 1 will become plus 2. And f of x is then 13 minus 2 lots of x plus 1 squared. So that's the form that we wanted it in. And then we can see from this that a is 13, b is minus 2, and c is 1. And then for part b, so we want to sketch the graph of the equation that we have above, and we want to state the coordinates where the curve crosses the y-axis. Okay, so if we have a quadratic in the form of a times x plus b squared plus c, the turning point of this quadratic is visible from the form that we have it in here. The turning point would be this number here times minus 1. That would be the x-coordinate, and the y-coordinate would be this, the plus c. So the turning point would be minus b, c. The a tells us something too. If a is positive, the quadratic looks like this, and if a is negative, the quadratic looks like this. So then what we have is 13 minus 2 lots of x plus 1 squared. So then following the same logic, our turning point would be minus 1, 13. And because we have a negative number in front of this x plus 1 squared, that means our quadratic looks like this. So we can now do a rough sketch of that. Has this kind of shape. This point here would be minus 1, 13. There's our y-axis, there's our x-axis, and we want to work out the coordinate where it hits the y-axis. So that will be when x is equal to 0. So we can do f of 0. We can put x is equal to 0 into this. We can equally put it into this expression over here, but it's a little bit easier to put it into this because these two terms just straight away become 0, and f of 0 is then 11. So this is 11, therefore the point that we have over here is 0, 11. And then for part C, we want to write down the equation of the line of symmetry. So the line of symmetry is this. Through the turning point, that is a vertical line. All vertical lines have equations of the form of x is equal to something, because every single point on that line has the same x-coordinate, and in this case, that x-coordinate is minus 1. So x is equal to minus 1. That is the equation of the line. So for part C, x is minus 1.